I'm going to talk about graphing linear equations. I'll assume that you know what a linear equation is. I'll also assume that you know the method of expressing solutions to linear equations involving placing numbers inside of parentheses, okay, separated by commas. If you're not familiar with any of that, I would invite you to watch my video introducing linear equations. All right, so let's start with an example linear equation. X plus y equals 1. All right, so you probably know how to find several solutions to this linear equation. Here's an example. Minus 1 comma 2, 0 comma 1, 1 comma 0, 2 comma minus 1, and so forth. Okay? Now, if you wanted to communicate all of the solutions, it would be impractical to give an infinitely long list. It would be impossible, actually. All right, so let me show you another way to communicate the set of solutions to this linear equation. Okay, now I'll assume you're familiar with locating numbers on a number line. Okay, what I'm going to do is I'm going to actually use two number lines. One of them is going to be horizontal and the other one's going to be vertical. So give me a minute to label points on each number line with numbers. And by the way, I'm going to refer to the horizontal number line as the X number line, or the X-axis, and the vertical number line as the Y number line, or the Y-axis. All right, so give me a minute to make some marks. All right, so I've put integers evenly spaced on both number lines. So what I'm going to do now is I'm going to place a dot somewhere on my picture with the two number lines, a dot for each solution that I've found. Okay, so let's start with the minus 1 comma 2 solution. All right, so what I'm going to do is I'm going to locate minus 1 on the number line, on the horizontal number line, and 2 on the vertical number line. Okay? Now I want to locate a point that is above the minus 1 on the horizontal number line and at the same height as the 2 on the vertical number line. Can you see that that would be the following blue dot? Let me repeat. It's above the minus 1 on the horizontal number line, and it's at the same height as the 2 on the vertical number line. Okay? So let's do some other examples. So the first number in each solution is going to represent the number I want to be above on what I call the x-axis. The second number is going to represent the height above the x-axis. All right. So 0 comma 1. So I want to be above the 0 on the horizontal or the x-axis, and at the same height as the 1 on the y-axis. So can you see that that's going to be that blue dot? Okay, and then 1 comma 0. I want to be above the 1 on the x-axis and as high as the 0 on the y-axis. So that's going to be, so I'm not actually above the x-axis. For that one, I'm actually going to be on the x-axis, okay? Because I'm at a height of 0, all right? And then for the 2 minus 1, I'm not going to be above 2, but because I'm at a height of minus 1, I'm actually going to be below 2 at a height of minus 1. So that will be roughly something about right there. And so suppose you kept doing this. Suppose we kept finding more and more solutions and putting more and more dots on our picture. Okay? You would notice that all of the dots would lie along that blue line. Okay? So this gives us a very nice way to express all the solutions to a linear equation. What we will do is we will create what's called an XY coordinate plane. Okay? We're going to create that with two perpendicular number lines. And then we will, using the method that I just showed you, we will locate a line on that picture. And that will represent all the solutions. Okay? Now, I located 4 points on the line. I think you would agree that if you had just 2 points, that's sufficient to identify, to define a line. Okay, so really you only need 2 points. Okay? Now, let me give you some definitions. Okay? Notice that one of the points is on the x-axis. Okay, namely the point 1, 0. Okay, that point is referred to as the x-intercept because it's on the x-axis. It intercepts that's where the line intercepts the x-axis, so to speak. Okay, now notice that the point 0, 1 on the is on the y-axis. Okay, that's where the line intercepts the y-axis, the vertical axis, so that's called the y-intercept. Okay? So hopefully that is clear, the method I elaborated to get a line corresponding to a linear equation. Let's do one more example, if that wasn't clear enough. Okay, what about this linear equation? What about x minus y equals 2? Okay, so we know how to list several solutions, but remember we only need 2 points to identify a line. So maybe we can be lazy this time. And let's just pick 2. How about 2, 0? And how about 1, minus 1? All right, so convince yourself that those are indeed solutions. Okay, and I will draw another XY coordinate plane. All right, so now let's locate the points that correspond to the two solutions. So 2, 0, that's instead of saying it's above the 2 or below the 2, it would be more general to say it's at this as far as to the right or to the left. It's at as far to the right from the origin as from the 0 as the number 2. Okay, so then it has to be above or below the number 2 or on the number 2 on the x-axis and at a height of 0, so that will be that blue dot. Okay, now let's do 1, minus 1. So the first number is a 1, the leftmost number, so that means I have to be above, on, or below the 1 on the x-axis, and then I'm at a height of minus 1, so I'm going to put a dot down right there. Okay, and so that's all we need to identify the line. Okay, now for this example, we would, and by the way, let me fix something. My -2 is too low. You'll see why in a minute. So what are the intercepts, the x and y intercepts for this line? Okay, can you see that the x-intercept is 2, 0, and can you see that the y-intercept after I corrected my y-axis is 0, -2? All right. Now, I hope that was clear because now I'm going to ask you to do an example. Would you please find the line that corresponds to the following linear equation? X plus y equals 2. Okay, I want you to make a picture of a line on an xy plane and also find the x and y intercepts. Okay, so pause the video and do that now, please. All right, so I'll go ahead and do it as well. So 0, 2 and 2, 0 are the intercepts. Okay, the 0, 2 is the y-intercept. And the 2, 0 is the x-intercept. By the way, I hope that you noticed a pattern. The y-intercept always has the first number 0. Okay, the x-intercept always has the second number 0. In fact, you don't even need to draw a picture to find the x and y intercepts. You just find the solution that has the x or the y 0, depending on which one you're looking for. Okay, so there's that, and we can use those to get our line. So give me a second to finish my picture of the xy coordinate plane. Okay, so 0, 2 right there, 2, 0 right there. So the line looks like that. And I hope that's what you got. All right, so now that we know how to find lines that correspond to linear equations, I'd like to introduce the definition of slope. Okay, so different linear equations will correspond to lines at different inclinations. Okay, in other words, if you think of it like a driveway, some driveways are steeper than others. Okay, so we need a way to measure the steepness or the inclination, whatever you want to call it, for a line. Okay, and that's what we refer to as the slope. And there's a very nice equation to find the slope of a line. What you do is you take 2 points on the line. It doesn't even matter what 2 points you pick. Let's say A, B and C, D are the 2 points that you determined were on the line that you wanted the slope for. Okay? You subtract the second numbers. You find the difference of the second numbers of each solution. So in other words, B minus D. Okay? Then you find the difference of the first numbers of each solution. In other words, A minus C. Okay? And that's the slope. All right? Now, if you pick, notice that B was in the leftmost point. Okay? If you pick the left one, if you put the left one first, you have to put the left one first on the bottom as well. So I did A minus C on bottom, not C minus A. Okay? If you chose the right point first, in other words, if you did D minus B, and then you also did C minus A, that would be the same thing. So the order doesn't matter. You just have to stick with a certain order. Either put the left numbers first or the right numbers first, and it has to be the same choice for the top and bottom. Okay? So the way that this is usually given in textbooks is they will say that you have a point x with a subscript 1, y with the subscript 1, and then they'll call the other point x with the subscript 2 and y with the subscript 2. Okay, and so then the slope is y2 minus y1 all over x2 minus x1. And traditionally the slope is denoted by the variable m. Okay? So write this formula down because we're going to use it now to calculate the slope of a line. Okay? So let me make a picture of a line. Just a minute. Have to make the xy coordinate plane. All right, and let's make our line, let's make it that one, okay? So let's find the slope of that line, okay? So as I said, it doesn't matter what points you pick on the line. I will pick the intercepts, although you don't have to, okay? And so the intercepts are 0, 2 and 1, 0. So for the slope, using that formula that I just mentioned, I'll do 2 minus 0 and 0 minus 1, and that simplifies to minus 2. Okay? Now, notice that if I started with the second point, the 1, 0, so if I did 0 minus 2 on top and 1 minus 0, I would still get minus 2. See that? Okay, so hopefully that makes sense. Now, let me do another example. Let's see, let's put a line this way. Okay, let's find the slope of that purple line. Okay, so it has the same x-intercept as the blue line, so 1, 0, and it also has it goes through the point 0, minus 2. So let me list those points. So 1, 0 and 0, minus 2. So calculating the slope, 0 minus minus 2 and 1 minus 0 gives 2. Okay, and if you did it in the reverse order, minus 2 minus 0 and 0 minus 1, you'll still get positive 2. Okay? Now, I would like you to do an example. So give me a moment to make another picture, and I'm going to ask you to calculate the slope of the line. Okay, so almost done. Okay, so that we all get the same answer, would you use the intercepts 0, comma 1 and 3, comma 0? Okay, so what is the slope of the line through the points 0, comma 1 and 3, comma 0? So find that slope now, please. Pause the video if you have to. Okay, so I'll go ahead and calculate it. So 1 minus 0 over 0 minus 3 gives minus 1/3. I hope that's what you got. Now, a common mistake is to put the difference of the second numbers on bottom instead of the top. All right? And also to start with maybe the 1 point in the difference on top, but start with a different point on the bottom. Okay, so watch for those mistakes. Okay, so what I mean by that, okay, so this would be a mistake if you did 0 minus 3 on top and 1 minus 0 on bottom. Okay, another mistake would be to say, oh, okay, I know I'm going to put the 1 minus 0 on top, but then on bottom you do 3 minus 0. Do you see how the order is different? Okay, I started with the y-intercept number first in the difference on top in the numerator. I have to start with the y-intercept number on bottom, so we can't switch that way. All right, now what about horizontal and vertical lines? Okay, what do their slopes look like? Okay, those are special situations. So let me talk about that right now for a little bit. Okay, so almost done. Okay, so what equation corresponds to the blue horizontal line that I've just drawn in the picture? Okay, well, it definitely corresponds to all the solutions definitely have the second number equal to 1, right? The height for every point on that blue line is 1. The x is all over the place. The equation that corresponds to is y equal to 1. Okay, so notice that equations of horizontal lines don't have an x variable in the equation. Okay? Now let's and by the way, the slope of that line, you can take any 2 points. Okay? Let me calculate the slope for 2 points. It doesn't really matter which ones you choose. I'll pick 1, 1 and 2, 1. Okay, so then the slope, remember the slope is denoted by m. That's 1 minus 1 over 2 minus 1, which is 0. Okay, so horizontal lines have equations of the form y equals a number, and their slopes are 0. All right, so now let's talk about a vertical line. So I will draw a vertical line on my picture. Okay, that purple line. So what can we say about that purple line? Well, every point on that line, the first number of every solution is going to be minus 1. Okay, the heights are all over the place. For that line, for vertical lines, for this one it'll be x equal to minus 1. That's the equation of that vertical line. For vertical lines in general, the equations won't have a y variable in the equation. It'll just be x equals a number. Okay, that one doesn't have a slope. Okay, let's try calculating a slope and see what happens. right, so what are those two, what are the coordinates? Coordinates are what I call the two numbers associated with points on an xy plane. So one of those purple points is associated with the numbers -1, 1. The other one is associated with -1, 0. If we tried to find the slope of that with respect to those 2 points, we would get 1 minus 0 on top and -1 minus -1 on bottom. But that's equal to 1 over 0, which is undefined. So that's why we say that vertical lines do not have a slope. Okay? All right, now let's do some more exercises to solidify all the things we've talked about. All right, draw a sketch of the graph associated with or corresponding to the equation x plus y equals -1, and also tell me what the slope is. Okay, so pause the video and do that now, please. All right, I'll go ahead and do it as well. So you only need 2 points to get a sketch of the line. That's good news. And we may as well choose the intercepts. Remember that the intercepts, we can just set x equal to 0 or y equal to 0 to get an intercept. All right, so 0, -1 is a point, is a solution to that equation, as well as -1, 0. All right, so let's see, a dot there and a dot there. And so the solution looks something like that. Okay, and then the slope. The slope is -1 minus 0 and 0 minus -1. That gives -1. All right. Now, would you please do this example? Find the graph, the line that corresponds to the linear equation 2x equals 1 minus y, and also find the slope again. Okay? So pause the video and do that now, please. All right, so I'll go ahead and make a sketch. Okay, so let's see, for one solution, how about 0, 1? And let's see, what else? How about 1, -1? I believe, let's see, plug in, replace x with 1, I get 2 on the left side. Replace y with -1, I get 2 on the right side. All right, there we go. All right, and so, yeah, now let's put our dots on the picture. So 0, 1 would be right there, and -1, -1 would be right there. And so the line looks something like this. All right, and the slope is 1 minus negative 1 over 0 minus 1 gives minus 2. Okay, and I hope that's what you got.